innovation of the platform, powertrain, but also the integration of that system into the car itself. It has to be more of a whole system as opposed to just a power plant or energy recovery system. I think CO2 emissions is obviously a powertrain area, but vehicle dynamics and aerodynamics has a huge amount to play in terms of the efficiency of the vehicle, whether it might be by weight or drag reduction or rolling resistance. So I think we have to look at it as an entire problem as opposed to just an engine emission problem.
The single biggest contribution we can make is to show very quickly, very efficient ways to increase efficiency of powertrains and cars in a very, very short time with very clear and obvious results. So this is a turning point of time, the new rules for 2014, because the first time it's not power and performance as the judging point, it's the efficiency, it means consumption, or specific consumption means gram per kilowatt an hour. This will be the deciding point from 2014 on, which every customer now is feeling it when he's going to a pump station, he has a car with a bad efficiency or bad consumption, then he has to fill up more often and is paying more. And that's what we want to work against via Motorsport.
Yes, I think Motorsport needs to evolve and to address more sustainable technologies and message. And I think it can do it in both directions, which are safety, which are very important for road cars, and which are energy efficiency in the whole. I think these are the two main targets for Motorsport to address road car industry. Then we also think in FIA is that we need to increase the value for stakeholders in motorsport, which means we need to look to have an eye on costs and also to increase the show. And we really need in many disciplines to make the show more attractive for spectators and for people in order to attract sponsors and so on. There are many examples in the past and in the future of technologies that can be transferred to road cars, perhaps not directly, but perhaps part of the technology can be transferred. I have a recent example is cars in Formula 1, which has very high energy density, and these are very small electric engines, and this is a source of inspiration for road cars, for example. So typically all the hybrid electric technologies can develop through motorsport and find applications in road cars.
The opportunity for motorsport to make a major contribution to the efficiency of tomorrow's vehicle is outstanding. We have the engineers. Formula One is full of the brightest and best engineers. All we need is some regulations that make the challenges for the automotive industry overlap very strongly with the challenges of making new race cars. We've got the engineers, they've got the facilities. We just need regulations that push and reward efficiency. That will do it.
I think the most important thing that motorsport can give to the car industry is the ability to innovate at speed. I've seen both from a perspective of being involved in motorsport, but also when I was in government, how motorsport has this incredible ability to come up with technology solutions fast, to implement them quickly, find out how well they're working, because you have to be there on race day, you can't be a day late, and that creates a culture of decision making. I think the most important areas of technology that motorsport can now offer to the automotive industry are around the innovations of the electric drivetrain, both hybrids and full electric cars, particularly addressing challenges such as cooling of electric motors, improving the energy efficiency of batteries, and getting the integration of the batteries, the inverters, the motors to really maximise the potential of electric cars.
Well, many people think that motorsport is just about competition. It's about efficiency, and I think we have a major role to play in building more efficient cars, which will see its way through into road cars, into the 95 gram per kilometre car. I also think that it's not just about the components, it's about the methodologies. And a lot of the methodologies that we have developed in motorsport are the methodologies that the OEMs now need to follow and to copy and to enhance to improve their products.
What motorsport can bring to reducing the pollution emission is really first the culture of racing, which develops strong engineering and can really help on this. But then to really help this, motorsports regulation must be driven towards this, with promoting new technology, with hybrids, electric vehicles, and adapts technical regulation as well as sporting regulation to drive innovation towards this. First, many things were carried out from race car in endurance racing to road cars. I think there is a great potential in the coming years to do this again. It's coming through new regulations, so we have new regulations coming in 2014, reducing fuel flow meter and promoting hybrid technology. It needs to go even further for the coming years. So we already need to think what's next after 2014 to really push development towards reducing fuel consumption and making racing car more efficient. But there are many aspects in which motorsports and endurance racing can contribute. On the Toyota TS030 project, we developed an hybrid system that is really in line with what you need on road cars.
I'm actually in the aerodynamic session, so therefore I try to focus making the cars sleeker and maybe less resistance. I will show some ideas about perhaps using blowing, some of the techniques that used in Formula 1. Maybe there's some angle of transforming those into passenger vehicles. Along the same line, you can develop maybe what's called acoustic synthetic blowing, which is acoustic excitation, and the final effect is very similar to the blowing that is used in Formula 1. And I think this has much more potential for passenger vehicles and could be also used in racing, and that way they can show the way how to use that type of technology. Otherwise, I kind of agree with most of the other people that maybe relaxing the rules could help improve technology transfer to the automotive industry. I would think that allowing more freedom under the vehicle instead of the flat bottom formula, or maybe allowing more engineering around the wheel to use pumping air and cooling, things like that. And some ideas like that would be very beneficial, and of course the rule makers have to listen to those kind of arguments.
Current aerodynamics of racing cars, as it was mentioned earlier in the presentation, is the methodology that we use to work with racing cars and with aerodynamics, to transfer that to the automotive industry. In terms of vehicle dynamics, again, is the methodology, but also the processes and the actual calculations we do to improve the vehicle dynamics of the car. In terms of aerodynamics, is the way we work with CFD, the way we work with wind tunnel, the way we work with validation of those two tools for the racetrack. That can be transferred directly into the automotive industry. In terms of vehicle dynamics, tire analysis, suspension analysis, control analysis, and stability, that is directly translatable to the motor car industry, because it's the same problem. We've got stability and control. We've got a different skill of drivers in one car or the other, but the problems and the physics are identical.
In my my view, the major contribution that racing can make to the road car powertrain is what I would define as attention to detail. All those detailed design, those small touches, which allows an engine to be absolutely optimum. It's very much what racing is about. It's about finding the optimum in the details. I'll take an example which might not come to everybody's mind straight away. Let's talk about an intake design. You find out that road engines tend to be quite compromised in terms of engine packaging, as one powertrain unit is supposed to go in many different cars. If you looked at it differently and say we are going to optimize that particular powertrain for that particular car, you could make some much less restrictive intake system, exhaust system, and therefore improve the efficiency of your powertrain by looking at those details, by ensuring that all the losses are under control.
I think that the most important story for the road car industry when they look at racing from an efficiency standpoint is to realise that racing is brilliant at efficiency. I mean, that is our fundamental job as engineers, is to make a more efficient car, and in an incredibly short time. So efficiency is what we've all been trained in, and in fact this era of low carbon future and 2020 cafe numbers and so on, this is our speciality. There has never been a time when racing has a greater part to play, in my opinion, in helping the auto industry meet its targets. Another important part of the story for the auto industry is that the racing car world is now producing engines that are running at high powers and high efficiencies, producing very specific fuel consumption numbers that are right where the best modern internal combustion engines are running on the road. So as racing, it feels like we must be gas burners, but in truth, we're running at the very edge of modern efficiency, right up in the high-end duty cycle.
What I think the racing industry can offer the automobile industry really is about the technology. And there's two aspects to that. The first is the technology of new innovative solutions to take the level of road cars to the next generation. And then the other aspect is the training of young engineers to be able to develop that talent for making decisions quickly and solving the problems in the shortest amount of time, which then improves the development cycle for automobile manufacturers.
I think if you look at motorsport and what it can bring to the wider world, automotive in particular, is the pace of development. And the reason that we have a good pace of development is because of the way we approach what we do, and that's where we use the power of data. So data to drive our decision making. Everything we collect is then used to help our decision making. We look at continuous improvement because we measure ourselves, because we know what our metrics are. We're always looking to try and improve upon them. And then leadership. And I think in that what we really mean is empowerment. And by empowerment we mean people make decisions quickly. Very often you don't have to refer your decision making up the chain, which is what takes a long time in a traditionally structured company. And because of that, we can make decisions quickly. And when the situation arises where you can't make a decision, it gets referred up and people know you've only asked because you need a decision made quickly. And so that's what I think we would bring in. And also obviously innovation, but then we're not the only industry in the world that's innovative. I would say that there is a different mindset to the way we do things because of the speed of operation. And the other thing that we talk about at Williams is brutal visibility, because when it goes wrong, 110 million people are watching on television. When it goes well, the same number are there. So it's about understanding the impact of when you make decisions and they don't go right, and how you learn from it, again, using the data, the leadership, the continuous improvement to make it go right the next time.
Well, from our world, I would have to say the electronic architecture at the heart of the Formula One car, which basically works on the principle of consolidation, where we consolidate all of the functional behaviour on the car into a centralised ECU.